Hello friends, welcome to my YouTube channel Video Updates. If you don't know me, I'm Rakesh Negi and I am an aviation enthusiast. In today's session, I'm going to discuss about the basic aircraft takeoff profile and some important considerations which are required to be made for determination of the aircraft performance during takeoff phase. So let us start the topic. Takeoff profile. So friends, let's discuss how is the basic aircraft takeoff profile. Suppose this is a point, okay, called as the brake release point. Release point. At this point, the aircraft is standing. Okay, so assume that the aircraft is standing at this point and the brakes are on. Now, if we want to go for takeoff, obviously we have to put off the brakes. So when you put off the brakes and apply the takeoff power, the aircraft will start accelerating, right? So as the aircraft is accelerating, there will come a point. Suppose this is the point, okay, where the pilot pulls the stick rearward so that the aircraft nose moves up. That is to increase the angle of attack. And once he pulls, the aircraft enters into a phase called as the rotation phase. Okay, here, which phase? Rotation. So the aircraft is entering into the rotation phase. So in the rotation phase, what is happening is acceleration is continuously achieved and simultaneously the aircraft angle of attack is also increasing. Okay, and then comes a point where the aircraft leaves the ground. Okay, suppose at this point the aircraft leaves the ground. So this point is called as the lift off. So when the aircraft tires leave the ground, the aircraft is into the lift off phase. The aircraft angle of attack is increasing like this. Okay, and when the angle of attack is increasing, the acceleration is also continuously achieved, and hence the aircraft enters into another phase which is called as the airborne acceleration phase. So till here is the lift off phase. Okay, from here till here. From here starts your airborne acceleration. Airborne acceleration phase. Okay. So from this point, when the aircraft lifts off the ground, it is going up like this. Then from this point onwards starts your airborne acceleration phase. So I have written it here, okay, by putting a dotted line and linking it here. So airborne acceleration state starts here. So what happens at this point from when the airborne acceleration phase starts? At this point, the ground effect, whatever would be there for the aircraft ends. I mean to say that is called as the ground reaction. Ground reactions, they start when the aircraft is in the takeoff roll and then it reaches till this point. That means the ground reactions, they are applicable till this point where the aircraft lifts off. So when the aircraft reaches this point, from here starts your airborne acceleration phase. And let me tell you friends, this phase from this point till this point is called as the ground acceleration phase. Ground acceleration phase. So what all do we have? We have ground acceleration phase, then rotation phase, and then airborne acceleration phase. So the ground acceleration phase starts from this point where you put off the brakes and apply the takeoff power, then the aircraft achieves acceleration until this point. At this point, the pilot pulls the stick rearward so that the angle of attack is increased, and this marks the beginning of the rotation phase. So the rotation phase continues, and then comes a point where the aircraft leaves the ground. Okay, so when the aircraft leaves the ground, that is called as a lift off. So from this point onwards starts your airborne acceleration phase, and this is your aircraft. Okay, hence this is called as the takeoff profile. Now friends, what you should note here is for determination of the aircraft performance during the takeoff phase, okay, there are certain important considerations. So I'll write them here. During takeoff phase, what are the important considerations? One of them is possibility of engine failure. Possibility of engine failure. Okay, means during the takeoff phase, the pilot should always consider the possibility of engine failure for determination of the aircraft performance. Okay. Now, this engine failure which we are saying, it should be the critical engine. Now, what is critical engine? Okay, as like in my previous session I have told, critical engine is that engine which when fails adversely affects the aircraft performance or handling qualities. Okay, and if I take an example of 4-engine aircraft, okay, the outer engine is an example of critical engine. Okay, and of course friends, in a 2-engine aircraft, the left or the right side engine, any one of them engine when fail, that is called as a critical engine. So friends, what we noted from here is, for determination of the aircraft performance during the takeoff phase, okay, the possibility of critical engine failure should always be considered by the pilot. Okay, and the possibility of critical engine failure should always be considered in the ground acceleration phase by the pilot. Okay, now let's move on to the next important consideration which is required during the takeoff phase. During the takeoff phase, the pilot must make sure that the speed and angle of attack are sufficient. I mean to say, whenever the aircraft in the takeoff phase, the pilot should assure that the speed is sufficient and also the angle of attack is sufficient, so that the lift and weight forces are in balance during the takeoff phase. So friends, these are the important considerations which are very important for determination of the aircraft performance during the takeoff phase. So friends, I hope you have understood whatever I have explained in today's session. I'll quickly summarize what we have discussed today. We have discussed about the takeoff profile, where we have discussed that initially the aircraft is at a point which is called as a brake release point, where the parking brakes are on. Okay. Now when you put out the brake, when the pilot puts out the brake and applies takeoff power, the aircraft will start accelerating. Okay. When the aircraft is accelerating, there will come a point where the pilot pulls the stick. Okay, so from this point to the point where the aircraft pulls the stick is called as the ground acceleration phase. After that, when it pulls the stick, this marks the beginning of rotation phase, wherein the aircraft angle of attack will start increasing with acceleration maintained. Now, there will come a point where the aircraft will leave the ground, or that's called as the lift off. So, and then starts your next phase, which is called as the airborne acceleration phase. So friends, these are the phases which we have discussed: ground acceleration phase, rotation phase, and airborne acceleration phase. Then we have discussed about some important considerations which are required for determination of the aircraft performance during takeoff. And those are, the first one is possibility of engine failure. That means for every takeoff, the pilot should always consider the possibility of engine failure, and that is the critical engine failure during the ground acceleration phase. Next, we have discussed that what is a critical engine. Critical engine is that engine which, when fails, adversely affect the aircraft performance and the handling qualities. Okay, like for a 4-engine aircraft, it is the outer engine, and for 2-engine aircraft, is any one of the engine whichever is running during the takeoff. Next, the other important consideration is speed and angle of attack. So during the takeoff phase, the pilot must assure that the speed is sufficient and also the angle of attack is sufficient, so that the lift and the weight forces are balanced during the takeoff phase. So friends, I hope you have enjoyed learning today's session. I'll come up again with a new topic in my next session. Till then, go through this session and thank you.